All right, in this video, we're going to solve these different logarithmic equations using some of the properties from the earlier sections. With condensing is what I'm mainly talking about, is when we see it, the word log written multiple times. Let's do it. We might use rewriting it in exponential form to solve it. So that's what I'm going to do here. On part A, we're going to remember that when there's no base on the g, that it's log base 10. So I'm going to rewrite this in exponential form. 10 squared is equal to 2x plus 1. And then I'm going to go ahead and solve that for x. And get 100 equals 2x plus 1. One step ahead of me on that one. Subtract the 1, I get 99 equals 2x. Divide by 2, and I get x is approximately 44.5. Or I guess we can say exactly because we didn't round, so we can say exactly. And then again, I should test that to see if it works. So I'm going to plug it in the calculator. Let's see if that works out. Does the log of 2 times 44.5 plus 1, does it equal 2? Well, let's take a look. Well, you let that be our guide. So does the log of 2 times 44.5 and then plus 1, what does that equal? And it's about 1.5, which rounds up to about 2. So that is pretty darn close. The next one, this one I want to get all the logs on one side so we can condense. So log base 2, add it over. So that gives me log base 2 of 4x plus log base 2 of x equals 2. Again, here, since we have an addition sign, that means that I can multiply the two parts together, this part and that part. So that means I can rewrite this as log base 2 of 4x times x. And that's equal to 2. So that gives me log base 2 of 4x squared equals 2. Now let's rewrite in exponential form. So 2 squared is equal to 4 times x squared. So 4 is equal to 4x squared. Divide by 4 as we start solving for that x. And then I take the square root of both sides. Remember, it's plus or minus. And that gives me that x is equal to plus or minus 1. Now I'm supposed to plug those back in to see which ones work. And this is where we got to remember, we cannot take the log of a 0 or a negative number. So when I go back to the original, I say, okay, log base 2 of 4x equals 2 minus log base 2 of x. I cannot put in an x equals negative 1 because that's going to make this a negative 4, which is a no-go. That's going to make that a negative 1, which is a no-go. So I really only have to worry about testing x equal to 1. And if that's the case, and if it doesn't work, then we get to say no solution. 4 times 1, log base 2 of 1. All right, so log base 2 of 4, does that equal 2 minus a log base 2 of 1? Well, I'm going to do this with some properties. This is log base 2 of 2 squared. Those cancel. I just get 2 on this side. I can rewrite, oh, sorry, not an equal sign there. I can rewrite log base 2 of 1 as the log base 2 of 2 to the 0 power. Now those cancel, and I get 2 minus 0, so 2 equals 2. So yes, x equal 1 is the solution. Again, if both of them didn't work, we'd say there's no solution to the problem. All right, now the hardest one. Whoops. The bottom one. That's the harder one. Same process. I didn't pre-write this one down, so let's rewrite it over here to the right. 2 ln x plus 1. 2 ln of x plus 1. Does that equal ln of 1 minus 2x? ln of 1 minus 2x. And I'm going to get rid of this calculator, give us some more room here. So now there's my problem. So let's go through and use a property to bring that, the power rule, the reverse power rule, bring that up top. So ln of x plus 1 quantity squared equals ln of 1 minus 2x. Using our power property for inverse, e to the ln of x plus 1 quantity squared equals, don't worry about that part, let's get that, erase, e to the ln of 1 minus 2x. And then with the e to the ln's cancel, and I get x plus 1 quantity squared equals 1 minus 2x. I need to go ahead and FOIL that out, x plus 1 times x plus 1, which will be x squared plus 2x plus 1. That's equal to 1 minus 2x. I now need to get everything on one side, solve for x, and in this case I'm going to get 2 because I got a quadratic, and I got to test both of them to see if they work. They may both work or they may not. So I'm going to go ahead and bring over the 2x and subtract the 1. So that gives me x squared plus 4x. That 1's cancel. I'm going to factor out an x. And this is going to give me my two answer choices of x equals 0 and x equals negative 4. Again, the ZPP, x equals 0, x plus 4 equals 0. So that one gives me x equals negative 4. So now let's go test them in the beginning. Is 2 times the ln of 0 plus 1, is that equal to the ln of 1 minus 2 times 0? So is 2 times the ln of 1 equal to the ln of 1? Because it'd be 2 times 0 is 0, so it's just ln of 1. ln of 1 is 0. The ln of 1 is 0, and 2 times 0 is 0. And so, yeah, that works. So we know x equal to 0 is a solution. Now I got to test the negative 4. So I have 2 times the ln of negative 4 plus 1. Is that equal to the ln of 1 minus 2 times a negative 4? And again, just because we have a negative number for x doesn't mean we have to stop. We should go through and plug it in and see. So is the ln of 1 plus 8, so that's the ln of 9. So this side looks good, it's the ln of 9. My challenge is the other side. Now I have the ln of negative 3. This is not possible. We can't do it. So x equals negative 4, not a solution. Remember, we cannot take the log or natural log. Doesn't matter what type of log it is. Can't do it of a negative number. So, so this one, since we can't do it from the left side for the balancing purposes, and we just stop and say, hey, that's not an answer choice. And that means our only solution is x equals 0.